We're going to cover divisibility tests in this video. Divisibility tests offer a quick way to determine if one number is a factor of another number. Remember, to be a factor, it means it divides into the other number without a remainder. So basically, divisibility tests tell you whether or not it's a factor without having to go ahead and do the long division. So we're going to go over divisibility tests for the first few prime numbers. As you learn these, keep in mind that each number has its own test. All right, the first prime number is 2, and the divisibility test is this. It's divisible by 2 if the last digit is 0, 2, 4, 6, or 8. In other words, if it's an even number. I imagine you probably already knew that. So, what if you were asked to circle the numbers divisible by 2? Could you do it? Here's 4 different numbers. You just circle the even ones, or where the last digit is 0, 2, 4, 6, or 8. So we've got that one, and those are the two numbers divisible by 2. The next prime number is 3. So here's the divisibility test for 3. The sum of the digits is divisible by 3. So what does that mean? Well, let's see. Let's say I was asked to circle the numbers divisible by 3. So the rule is that you're going to do the sum of the digits. So for 56, what are the digits? 5 and 6. So let's do it over here. 5 and 6 is 11. Does 3 go into 11? No. All right, let's do the next one. The digits are 3 and 7. 3 and 7 add up to 10. Does 3 go into 10? No. All right, how about 42? 4 plus 2 is 6. Does 3 go into 6? Yes. So 42 is divisible by 3. Now that you know it's divisible by 3, that means you can go ahead and do the division, and you'll be able to find out how many times 3 goes into 42. All right, how about 87? The digits are 8 and 7. 8 and 7 add up to 15. Does 3 go into 15? Yes. That means 3 also goes into 87. How about 151? Well, there's 3 digits, so add all 3 of them up. 1, 5, and 1 is 7. Does 3 go into 7? No. So these are the only numbers of this list that are divisible by 3. Now, there's something really interesting here. It doesn't matter the order of the digits. If I switch the order of these digits, the answer would be the same. For instance, if the number was 65, 3 doesn't go into 65 either, because 6 and 5 add up to 11, and 3 doesn't go into 11. Or 73. It's not going to go into 73 because, again, the digits add up to 10. Now, what if you switch the digits on 42? 24. Most of you already know that 3 goes into 24, right? 8 times from your times tables. But another reason is because the digits, 2 plus 4 add up to 6, and 3 goes into 6. How about 78? Did you know 3 went into 78? Well, it does because 7 and 8 is 15, and 3 goes into 15. So I know that these two numbers are also divisible by 3. Now, what about 151? I could change the order around here, and the answer, no matter how I do it, it's not going to be divisible. So if I did 115, so I'm sort of switching the order here, or if I did 511, those are also not going to be divisible by 3, because when you add the digits, you're going to get 7, and 3 doesn't go into 7. So that's a pretty cool divisibility test. You simply add the digits. If you've got 5 digits, like 24,396, etc., you would go ahead and add those digits as well. The next prime number is 5. So here's the divisibility test for 5. The last digit is 0 or 5. I bet a lot of you knew that as well. So you simply look at the last digit to decide if 5 would go into the number evenly. So here are 5 numbers. Which ones would be divisible by 5? Only the ones that end in 0 or 5. So 600, 855, and 9325. 5's pretty simple. 2's pretty easy. 5's pretty easy. 3 might be the new one for you. The next prime number is 7. So this is harder to explain than just do. Here's what you do. You cross off the last digit, double it, and subtract. You repeat if you want. If the new number is divisible by 7, the original number is divisible by 7. Okay, it sounds like a mouthful, but let's do it. Circle the numbers divisible by 7. 583. All right, so we want to know 583. So we take the number 583. All right, and what you do is you cross off the 3. Okay, so watch. Cross it off and double it. So that's going to be a 6, right? And you subtract. And you get 52. Does 7 go into 52 evenly? No. What if you're not sure? Well, you could do it again. Go ahead and cross off the 2. That's the last digit. Double it. And you get 1. Does 7 go into 1 evenly? No. So I'm not going to circle 583. 7 does not go into 583. Of course, you could check this with a calculator too. You'll see you're going to get a remainder. All right, let's do the next one, 91. So if I start with the number 91, I'd cross off the last digit, double it, and subtract from what's left. So I cross off the 1. 1 times 2 is 2, and I get 7. Does 7 go into 7? Yes. So 91 is divisible by 7. By the way, a lot of people think 91 is prime. There's no number that goes into it, but 7 goes into it. It's easy to tell if you just do that little divisibility test. Let's do a couple other numbers. All right, how about 648? So let's do it over here. So we have 648. What are we going to do? We're going to cross off the 8, double it. That's 16, right? And subtract 16. All right, now of course you have to remember how to subtract 16. There's lots of ways to do this. 48. Does 7 go into 48? No. So you know what? Doesn't go into 648 either. All right, if the answer is no, it does not go into it. So let's do 175. So we start off by writing 175. And let's cross off the last digit and double it and subtract. So if I double 5, I get 10. 7. Does 7 go into 7? Yes. So this is one that a lot of people don't know, but it's just a quick and easy way to tell if 7 goes into a number. Let's do another number. All right, let's see if 7 goes into 3,724. All right, so what are we going to do? I'm going to do it over to the side, so if we want to circle it, well, we can do that easily. So we're going to cross off the last digit and double it. 4 times 2 is 8. And then we have to subtract, all right? So you've got to subtract. Everyone do that. 372 minus 8 is 364. Well, I don't know if 7 goes into that either, so I'm just going to do it again. Cross off the last digit. Also happens to be 4 again. Could have been any number. And double it, you get 8. So I'm going to subtract 8. And I get 28. Now, does 7 go into 28? Yes. So that means 7 goes into 3724. So practice this on a few numbers. 11 is the next prime number, and this will be the last divisibility test we'll go over. For a 3-digit number, the sum of the outside digits minus the middle digit must be 0 or 11 to be divisible by 11. So let's circle which of these 4 numbers is divisible by 11. We take the sum of the outside digits for 768. 7 plus 8 is 15 minus 6, and that gives you a 9. Well, that's not 0 or 11, so that didn't work. How about 462? Take the outside digits. 4 plus 2 is 6, minus 6 is 0. Yes! So you know what? 462 is divisible by 11. You can check that in your calculator. And the next one, the outside digits, 9 plus 4 add up to 13. Minus 2, I got 11. Cool. It's also divisible by 11. And the last one, 8 plus 1 is 9. minus 7, which is 2. That is not divisible by 11. So 462 and 924 are the only numbers divisible by 11. So here are the divisibility tests for 2, 3, 5, 7, and 11. This just tells you whether 2, 3, 5, 7, or 11 is a factor of a given number. And if it is, then you go ahead and divide and it'll go in without a remainder.